Hello students, I am teacher Anuja from the Wave Private School. So we are going to continue with the part 3 for topic air and water. This topic is for grade 10 from Cambridge IGCSE Chemistry course book. Let us proceed with this topic. The objectives which we learned in previous video, that was part 2 of air and water, the objectives were air pollution and nitrogen oxide in car engine. In air pollution we saw how air is polluted and because of which air, like what type of air are present, and those are carbon monoxide, sulfur dioxide, oxides of nitrogen and compounds of lead. And in nitrogen oxides in car engine we saw there is a converter which is there is a honeycomb, the catalytic honeycomb, which helps to convert the harmful air of carbon monoxide and nitrogenous oxide, and which gives out the harmless air. Okay, and we saw there was the presence of catalytic converter. Okay, now let us proceed to our part 3. The next objective is the rusting of iron. Now see student, this image, you can see this nail which is rusted. So what exactly happens? Why this occurs? So this is called rusting of iron. These nails are made of iron which cause rusting. Okay, now see what is rusting. It is the chemical reaction between iron, water and oxygen that forms the compound iron oxide. Now see student, these are the nails, they are made of iron, but when it comes with the contact of water and air, they form iron oxide, which gives the concept of rusting. Got it? So oxygen and water must be present for rust to occur. Rusting is a redox process. What is redox process? It is the process in which there is oxidation and reduction. Students, we have learned this oxidation and reduction in redox chapter, that was for your previous semester. We have learned oxidation means loss of electron, reduction means gain of electron. Okay, and it occurs faster in salt water since the presence of sodium chloride increases the electrical conductivity of the water. So when there is presence of sodium chloride, what is sodium chloride? It is NaCl. Okay, what is NaCl? That is salt. Okay, so it helps the increase the electrical conductivity of the water. Okay, now let's see the reaction. That is iron. What is the symbol of iron? That is Fe. When it reacts with water and oxygen, it gives hydrated iron oxide. Now what is hydrated? Hydrated means in which there is presence of water. Okay, presence of water. In first video we saw anhydrous. Okay, so what is anhydrous? Anhydrous is there is no presence of water. Got it? The meaning of hydrous and anhydrous? Yes. Now see, in this 3 test tube you can see the nail, it is in water and it is also in contact with air. There is open space from the above of the test tube, so you can see there is rust occurring. But in second test tube you can see the nail which is in boiled water. Okay, so there is boiling of water, so even by the presence of water and air there is no rust. Why? Because the water is boiling. And in third test tube you can see there is air but no water. Even when it is coming in contact with air, it is not rusting. Why? Because there is presence of calcium chloride. Got it? So got the concept, the rusting of iron, why there is rust of the iron. You can see like this, like to the bicycles and any steel material which are like old and which are we don't use it regularly. So when they come in contact, they rust. So like this you can see. So got it why this occurs? Because they come in contact with water and oxygen. Let us proceed next. We saw the concept rusting of iron, but there must be some method where we can stop this rusting. So there is one method, that is rust prevention. Okay, so see student, iron can be prevented from rusting using the reactivity series, that is galvanizing process. So this is the process in which the iron is protected by the cover of zinc. Now see zinc, it used as the protection for the iron to protect it from rust. So what happened is zinc carbonate is formed when zinc reacts with oxygen and carbon dioxide in air, and it protects the iron by the barrier method. Got this student? Now see, zinc carbonate, it is formed when it reacts with oxygen and carbon dioxide in the air. So zinc, when it comes in the air, it reacts with oxygen and carbon dioxide and it protects the iron from getting rust. So if the coating is damaged or scratched, the iron is still protected from rusting by the sacrified method, that is magnesium. Okay, so magnesium is also used, which can prevent the rusting method. This is because zinc is more reactive than iron, and so it loses its electron. Now see, loses means oxidation. See student, in redox reaction we have learned loses means oxidation. When there is loss of electron, it means that is oxidation. It loses its electron more readily. Now see this zinc. So it is losing electron. You can see zinc, that gives zinc 2 plus plus 2 electron. There is loss of 2 electron. Got it? So zinc helps to protect iron from rusting. Now we are going to learn about fertilizer. So what is fertilizer? It means soil. The soil which is used for the growth of the plant. So which elements are present in soil which gives the fertility to the plant, leaf, its root and stem. So now we are going to see the concept about the fertilizer, like what exactly the elements are present in the fertilizer and what are its sources and its ability that helps the fertilizer to fertilize and give growth to plants. So let's see with the concept that is called NPK fertilizers. Now student, tell me what is N? That is nitrogen. P is phosphorus and K is, what is K? It is potassium. Okay, so see now, fertilizers contain nitrogen, potassium and phosphorus. So nitrogen promotes healthy leaves. So what is the work of nitrogen? We will see for first nitrogen. It promotes healthy leaves. The work of potassium, it promotes growth and healthy fruit and flowers. And phosphorus, it promotes healthy roots. So got it? The work of nitrogen, potassium and phosphorus, they help the fertilizer to promote healthy leaves, then promote growth and healthy fruit and flower, and phosphorus, it helps for healthy roots. Now in fertilizers, the compounds that contain the following water soluble ions, and those are, see, ammonium ions and nitrite ions. They are source of soluble nitrogen. So in nitrogen, the soluble Sources are ammonia, iron and nitrite ions. In phosphorus there is phosphate ions. Okay. Most common potassium compounds dissolve in water to produce potassium ions. So potassium, when they dissolve in water, they gives potassium ion, that is K plus. Got this concept? Now we are going to see the manufacture of ammonia, that is NH4. How ammonia is produced. You know now what is the formula of ammonia? That is NH4. Okay, NH4. It means there is nitrogen and oxygen gas present in it. Now let's see step by step. Okay, now see, first we will see the step 1. Before that, let's understand there are 5 steps. Okay, see, hydrogen and nitrogen are obtained from natural gas and the air respectively are pumped into the compressor through pipes. In second step, the gases are compressed to about 200 atmosphere inside the compressor. Third step is the pressurized gas are pumped in the tank containing the catalyst ion beads at the temperature of 450. So in that process, the hydrogen and nitrogen react with ammonia. See the reaction when nitrogen reacts with hydrogen, it gives 2NH3. Okay. See, stage 4 is the unreacted H2 and N2 are product ammonia pass into cooling tank. The ammonia is liquefied and removed to pressurized storage vessel. And stage 5 is the unreacted H2N2 gases are recycled back in the system and start over again. Now see student, we will understand this by the diagram. See, this is the diagram. You can see there is the passing of hydrogen and nitrogen gas which are obtained from the natural gas. Okay, and they are pumped upside, and you can see this goes in this coolant. Okay, and some goes in this tanker. So these gases are first compressed, okay, compressed to about 200 atmosphere inside the compressor. It means it is like pressed from upside, and then the pressurized gas are pumped into the tank containing the layer of catalytic ion beds. Now see, these are the catalytic ion beds at the temperature of 450. Okay, so in that, this only some of the hydrogen and nitrogen react to give ammonia. Got this? And you can see in this the coolant which is coming out, and in this this is the process where nitrogen and hydrogen combine. Okay, and the leftover H2 and N2, it goes in this, and then again it comes, it starts. So see student, you can see this from here, it is coming inside, and from here it is going here. From here you can see the reacted N2 and H2 which is giving ammonia, and the unreacted which is not reacted, that is passing through this, and then again it is coming here. So it is recycled. The unreacted is again coming in the same pipe from the upper side, and it is going in the catalyst section, and then again in compressor section. So got it, how ammonia is manufactured? And this process is called Haber process. That process is called Haber process. So the question can be asked like for which process is used for the manufacture of ammonia. So which process is used? That is Haber process. So this all objective we learned in this part. So in part 3 video, we learned the objectives, the rusting of iron. In that we saw the iron, when it comes with contact with air, it rusts. Okay. Then we saw the method of rust prevention. What is used to prevent iron into rust? That is zinc. Okay. zinc, and then we saw NPK fertilizer, that is nitrogen, phosphorus and potassium. After that we saw manufacture of ammonia. So next objective we will continue in part 4.